Good day, good people. Welcome to JJ Tech Tutoring. Today's lesson is going to be so easy and very short. I'll be taking you guys through Laplace transform of unit step functions. I'll do a couple of examples bit by bit up until I get to do you exam questions, exam types of questions, whereby you're gonna be able to apply this. And then if you get to follow along, you might as well not need the table. I just wrote the table so that you guys can see where I'm coming from. But then there is no need for you to cram the table, because it takes time when you're writing an exam that you have to go to check the table and all. And then some schools don't give tables, and then table is just useless. If you're doing maths, you must have these things in your blood. You must try by all means to practice very hard. The more you practice, the more you can master the table. All right. So now, first thing first, I will give the examples of the first or the 27th part of Laplace transform. Right? So it's saying ut minus a is equals to, so that means now you take this, put it here, then you divide by, or you multiply by the Laplace of this, because here there is 1, so that means this, it's actually the Laplace of 1 multiplied by a to the power negative as, right? So the Laplace of 1 is just 1 over s, then multiplied by e negative as. So that is why it's like this. Sometimes we must dive into where things are coming from, right? So that's when you will understand mathematics, right? So the second one, it is just a straightforward one. If the function of if your function is actually having something that is similar to this one, you just have to do this and take the function, right? And then if your function, it is not supporting actually this part, right? That means you have to substitute by the conjugate of this, right? So that means you have to substitute and find the Laplace transform of the conjugate of this function. So that means you have to substitute by t, the conjugate of this, it will be plus a, to this equation, right? Then from there, you find the Laplace of this equation, right? As easy as that. Now let us try to do example of each of the three of this table, right? So now, first thing first, we have to start with this, right? So say you are given something like 8 ut minus 4, right? And then obviously they will want you to find the Laplace transform of this, right? So now, first thing first, the Laplace transform of 8 is 8 over s, right? So you multiply it by, now you are dealing with this part, you multiply it by negative 4s, right? Negative 4s, right? And then why are we picking this negative? Because our a is negative 4, right? Our a is negative 4. See what? Let us do another example. Let's say 15 ut plus pi. So you can just find the Laplace transform of this. It's going to be 50 over s, right? Then e, then pi s, right? As easy as that, right? This is the first part, right? So that means now, with or without this table, now you can be able to solve if you are given something like this, or if you are given something like this, for as long as it doesn't have the function here, for as long as it's not 8t, for as long as next it's not 15t, right? So that's how you're gonna be able to deal with it. Now, say what? Say you're given Laplace transform of t minus 2 ut minus 2, right? So now that means this one is exactly like number 28. It's exactly like this number, right? So it's easy, because you just have to say a to the power negative 2s, then you find the Laplace transform of f of t. And then your f of t here, in this case, is just t. Your f of t is t, because it's subtracting exactly the same thing that is in this side. Don't confuse the two. It is just the same, right? I'm gonna give you, or try to give you, the difference between this and this, because some don't get the difference, right? So you might make silly mistakes. Now, negative 2s, then we're gonna get t here. Then from there, it's negative 2s. Then the Laplace transform of this t is just 1 over s squared, right? So that means it will be e negative 2 over s squared over s squared. Just as simple as that. As simple as that. Now, say what? Say you're given, because the more we do examples, the more you get to realize which one is which. Now, let's do this. Let's do this. Let's do this one. Sine t minus 1 u t minus 1. How can we go about this? Right? So since we have done this part, and then if ever you haven't practiced such things, or you haven't went through Laplace transform of unit step function, or you just want to be ahead of your lecturers, now you can pause the video and then try to solve this using the same method. Right? Using the same method. I know it is a little bit different from here. It's a little bit different here. It's actually a little bit different. Right? It's a little bit different, but then it's easy because in this, we said immediately it is subtracting the same with this. That means we have to just find the Laplace of just the f of t part, right? So now our f of t, it's sine t, right? It's sine t because it's just subtracting the same with this. If here was positive 1, that means it was not going to be the exact function. It was not going to be the function. We're going to use another method or another formula, right? So now you just have to e negative 1s, the Laplace transform of sine t. The Laplace transform of sine t. So the Laplace transform of sine t is just 1 over s squared plus 1, right? So you just have s squared plus 1. So that's how it is. That's how it is. That's how easy it is, actually. That's how easy it is. Now, say what? Say you're given something like s. Okay, let's say the Laplace transform of t squared minus 2, right? T squared minus 2 u t minus 1. You see, now there is a difference. This is the function that is standing on its own. This function, it is actually standing on its own. That is why now, in this kind of functions, we just have to do what? It's a to the power negative 1, right? S, right? Now, you have to find the Laplace transform of this function substituted with the conjugate of this, right? Because it's just f of t u t minus a. This is just e negative as, right? Then from there, you find the Laplace transform of the conjugate, right? Substituted by the conjugate. Now, so the conjugate of this is just t plus 1, right? This is the conjugate of this. So it's just going to be t plus 1 squared minus 2, right? Right? So now, t plus, then we just have to solve this out. So it's t plus 1 squared minus 2. So it's t plus 1 minus 2. So it's t squared plus t plus 1 minus 2. Then it's t squared plus 2t plus 1 minus 2. So it's t squared plus 2t. Then 1 minus 2 is minus 1. So that means we have our f of t plus 1 is equals to t squared plus 2t minus 1, right? So now that's the thing that we need to now do the Laplace transform of ours. So it's just going to be here. And then we do the Laplace transform of t squared plus 2t minus 1, right? Minus 1. Then from there, e is just going to be the Laplace transform of t squared is just 1 over s cubed plus 2 over s squared minus 1 over s. So those are the Laplace transform of them. So you just leave it here. Leave it here before you run it. Leave it here. That's how it is. That's how easy it is. That's how easy it is. I don't know which kind of questions do I have to do now, but with this, you are very much safe. With this, you are very much safe. Let's say you're given something like what? Let's say you're given something like what? You're given something like e to the power t u t minus 3, right? So with this, automatically you will have to understand that this function is totally different from this part, right? So now, easy peasy, you just have to come, okay, e to the power negative 3s, right? The Laplace transform of f of t plus 3, because it's the conjugate of this, right? So it's just going to be e negative 3s. Then let's find the conjugate of this. So it's just gonna be e t plus 3, right? E t plus 3, because now that's how it is. Now we have to find the Laplace transform of this. Okay, we have to find the Laplace transform of this. So now, what is it that is going to be the Laplace transform of this? So now let us try something. Let us try something out here. Let us try something out here. It's maths. It's maths. It's maths. T. Right. So now, do you get the combination? Laplace transformation, the one that is even shifting. I did this kind of Laplace transform in this channel. You can just go and check it out. Go and check it out, or I will put it in the description, so that you can just go and follow the link, so that you can understand, or what is it that we do when we are given something like this, right? So now we have to find the Laplace transform of this. Then from there we just shift it, right? We just shift it. Now, what we have to do now, since it's positive, it's going to shift to the negative, right? So it's just gonna be e negative 3s. Then from there you put your aside, because this is the one that we have to do the Laplace transform of, right? So Laplace transform of this is, right? So now that we have s, in s we have to put s minus 1, right? Because here there is 1, right? So that means it's going to be what? E negative 3s e 3 s minus 1, s minus 1, s minus 1. So there is this, right? You can just leave it here, or if you are enjoying mathematics, you can just do something. S multiplied by e3 divided by s minus 1, right? You can just do something when you are enjoying mathematics, right? So you just take this one, we add the exponent, right? We take one base and add the exponent, right? Add the exponent. Then from there you can just continue. When you are enjoying maths, then you just say e negative 3 s minus 1, s minus 1. So this can be your final Laplace transform question, right? This can be your Laplace transform final answer. So that's how easy it is. That's how easy it is. I'm not sure if I should do another one, but then so far we are fine. We are cool. You can kill the exam, or you can kill all of those Laplace transform stuff and all. So this was just about these three parts. Stay tuned, hit the bell icon, and then make sure that when I upload many things, you're gonna see them. Thank you so much for subscribing, those who subscribe, and thank you so much for liking, for those who are always liking, sharing, right? Stay tuned, because I'm going to upload the most challenging chapter, which is Fourier series. Thank you.